Good afternoon, everybody. My name is Ricardo. I work for Confluent as a developer advocate. I'm going to try to do this presentation as entertaining and engaging as possible because, come on, it is the last presentation of the day. And most importantly, we have an happy hour after this. So probably you guys are only thinking on that. Although the title of this presentation is kind of a very long, right? There are two things that I would like to explain in this presentation, right? The first one and most important one is how to implement observability, period, for now, right? Observability, that's the topic that we are going to talk about in this presentation. But more importantly is where we are going to implement observability, which is in the area of stream processing, which is what Confluent and Apache Kafka, which is the technology that we work at Confluent, is kind of a specialized to. All right. All right, so a little bit about me. Actually, this is me dressed up as Deadpool in a conference this year. And this is my favorite character ever, so I like it very much. As I said, I'm a developer advocate at Confluent, and my role at the company is focus on everything that's related to cloud. So I definitely have the toughest job between all the other developer advocates because they have the advantage of run their demos locally in Docker or whatever container they would like to use. But my role, I have to run everything on cloud. So if I don't have internet connection, I'm screwed. So in matter of fact, that happened 2 hours ago. So probably we won't have any demos today, but hopefully it's working. The way I like to explain myself these days is that I'm 70% dev and 30% ops. And the reason for this is that I've always been a software engineer all my life, but the last 5 years, I've kind of been involved on the ops part, which is I'm in love as of now, and hopefully by this time next year, I'll be 50-50. But first of it, I have to learn how to use VI properly. So until there, help me God. All right, get to the point. So the agenda for today is, as I told you, talk a little bit about stream processing. All right, it's kind of a fuzzy concept these days. I mean, conceptually, everybody understands what stream processing is, but pragmatically speaking, what is stream processing? Have you seen stream processing? Have you implemented stream processing? I know that Spotify does streaming. I know that Netflix does streaming, but what stream processing really is, right? So that's what we're going to address here, and that's where I kind of brought a demo for us. Well, we're kind of going to exercise a little bit, and then after this, we are going to discuss a little bit about the challenges of observability into stream processing, all right? And finally, of course, I'm not going to simply throw the questions here and then not solve them. So the last part is going to actually to show you how I did implementation of observability into this demo right here, all right? So hopefully it's still working. So if you don't mind, I want to check if everything's kind of still working now. So those are my AWS endpoints where I'm going to do a quick test here, author from. I forgot that was on, so sorry about that. I brought something very special that usually called by the name of Alexa, right? Have you heard about Alexa? Not you, Alexa. All right, so let me see if it's working. One. Alexa, stop. For now. What I'm going to do here, guys, is I'm going to ask her to shuffle songs for a specific author or any particular song. It's configured to use Spotify as the engine for streaming, music streaming. So every song that's kind of streamed by her, I'm going to show up here in this query. So the name of the song and the author of the song. So let's try that out. What kind of a band or do you like to hear? Anyone? Bon Jovi? Could be? I would rather not because I cannot pronounce that name. I'm from Brazil. My accent's too strong. So if you want to ask her, I wouldn't mind. So let's try Bon Jovi because it's easier to pronounce. Alexa, shuffle songs from Bon Jovi.
Shuffling songs by Bon Jovi from Spotify.
Let's see. Famous one, Leave It on a Prayer, right? So you get the point. every song that I ask her to play, it will be streamed to my Kafka cluster. All right? Alexa, stop for now. So I have a Kafka up and running on AWS right now. So everything that we're going to process here is actually passing through a Kafka topic. So that's going to make things more interesting. So the intention of this game is for you to figure out what song I'm playing it. How many of you use Twitter? That's a good question. Oh, that's going to be a problem. OK. All right. OK, for those of you that has Twitter, you will get to choose what the song is playing. And if you get it right, you are going to be rewarded, right? With Apache Kafka. It's here. It should be OK. All right, for those of you that doesn't use Twitter, probably is a good idea to sign up right now. So if you want to get a Apache Kafka book or a T-shirt for Kafka, that's the time. All right. So let me do a quick dry run so I can show you how it works, and then we can play for real. Meanwhile, you can sign up for Twitter. All right. All right. Let's see if it's working. So I'm gonna ask her to continue the music, and then I'm gonna tweet to show you how it works, and then you're gonna kind of see the whole game going on. Alexa, continue. Actually, Alexa, next one. I don't like this one.
Sorry, I'm not sure about that.
Alexa, next one. Right. So I'm going to cheat and copy the name of the song. All right? So what you're going to do on Twitter is this. You're going to use the hashtag DOTCNZ, right? This is mandatory, otherwise I'm not going to scan it, all the Twitters. And between brackets, you're going to say the name of the song, all right? So what's going to happen after this is, you see that the music stopped automatically? Because my string processing detected that some winner came up. And it sent a trigger for Alexa to stop the music. So now I can ask her, Alexa, who is the winner?
I couldn't find any games.
I tested this for the last 2 months, I promise you. So let's try again.
Sorry, I'm not sure about that.
This is part of the presentation to make it fun, you know? Alexa, stop. Alexa, tell me who is the winner. I'm playing some cha-cha-cha meanwhile.
The winner is Ricardo Ferreira. Congratulations.
All right. Oh, cool. So the whole point is, there's data coming from Twitter. It passed through Kafka. There's some string processing going on. And then the result of the string processing goes to Alexa. That's the whole, not to you, not talk now. The whole point of this string processing is to do this.
I don't know that one.
Alexa, stop. So what I'm going to do now is I'm going to remove the column name of the song for obvious reason. All right? Alexa, tell the demo to remove all winners.
Okay, all winners are gone. Ready to play.
Okay. So now that we are kind of you only see the author, I'm going to play some songs, and you get to figure out what song is. All right? You have any preference about 90s, 80s to make it easier? Or I can play something random for sure. Let me play something random. So I would test your music skills for. All right. Okay, let's try this one. Kind of a hit parade right now. Office. You can tweet if you want it.
Somebody save your soul, cause you've been sinning in the city. I know too many troubles, all these lovers got you losing control. You like a drug to me, a luxury, my sugar and gold. I want the good life every good night, you're a hot one.
Well, I'm gonna give you a tip.
Cause you don't even know. I can make your hands clap. Said I can make your hands clap. Somebody save your soul, cause you've been sinning.
Oh. Oh, that's a good situation that's going on right here. So apparently 2 persons kind of got it right, Jennifer and Jiraj. Did I pronounce correctly? Jiraj? All right, cool. So let's see if I ask her which is the source of truth. Alexa, tell me who is the winner.
The winner is Jennifer Pedoff at #Dawkins. Congratulations.
All right. See, right? Okay. You can split the book in half.
Thanks very much.
All right, good job.
Thanks.
All right. Okay, so the reason why Alexa chose Jennifer is because every time a winner comes up, I have a timestamp, right? So the timestamp, even for a fraction of milliseconds, someone is gonna get it first, right? Which was Jennifer. So although you get it right, sorry about that, but you were the second. But as a reward, I'm gonna give you a t-shirt because you got it right? Can be large. All right. Let's play again, one more time. And then we can move forward. You got the spirit of the game, right? So I'm gonna leave the, so this is how you tweet. And I'm gonna leave the window right here kind of open so we can follow up. All right. New one. My favorite song ever after I watched the movie White Chicks.
Making my way downtown, walking fast, faces pass and I'm homebound.
All right. You saw the movie, right? You love Latrell like me. Alexa, tell me who is the winner.
The winner is Jennifer Pedoff at #Dawkins. Congratulations.
One more time. Actually, I think I forgot to do something. Alexa, tell the demo to remove all winners.
I couldn't find any games.
Whatever. Who is Joel? Who is Joel? Okay.
Alexa Ray Joel is 33 years old. Did that
Really?
answer your question?
Alexa, stop. Here you go, bud.
Thank you very much.
You're welcome. All right, so what happened here is that I have this, I'm gonna explain the architecture of this later, but I have a Redis cache which kind of holds all the winners. So every time we have to play it again, I forgot to tell Alexa to clear the cache, right? Because, so the last name for the cache was Jennifer. All right, for those of you that didn't got the book, don't worry, because, guess what? You can scan this barcode and get it for free. All right, so I've made available this presentation here at my blog, so you can just go there, /presentation. The presentation is going to be there, so don't worry to kind of scan it right now. But all those books are kind of available right there as for free. The first one is my favorite. Like, if you want to understand a little bit about how Kafka works, this is the way to go. And the last one is very good if you want to know how to implement microservices correlation and coordinations using Kafka, like how to communicate using Kafka, still ensuring eventual consistency. It's pretty cool. It's pretty good. All right, So as I told you, this is the architecture that I was using this application. So for the user perspective, right? For the user perspective, this was me, right? Without space. And every time I interacted with her, I'm not going to say her name because otherwise it's going to say blah, 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 blah. She invoked a AWS Lambda endpoint, right? And this Lambda endpoint was kind of accessing the Redis cache to look up for the winners, right? But how the winners end up there? That's the beauty of stream processing application, because as you can see here, I have the information coming from Twitter, which someone's kind of go there and tweet, right? And I have this information being stored on Kafka, right? And I have a Spring Boot application that picks up this information. It processes to read the information between the brackets, right? And after this, it sends the data back to Kafka, all right? And then what happens is that, have you seen this logo before? This is a technology that is part of the Kafka ecosystem called KSQL or KSQL, whatever you want to call it, right? So this is a technology that does this. Not sure if you paid attention when I was kind of interacting with the cluster. It does this. You can express your stream processing as if you were building SQL code, right? So if we think, if you ask, show streams. So this is all the streams that I'm kind of working on right here. How many of you have implemented ETL in databases? ETL batches, ETL processes. Guys, this is exactly the same thing, right? So stream processing is how do you read data from the source, but before delivering the data to the destination, you do in-between processing or stages of processing or data lakes, whatever you want to call it, right? So this is kind of the future of how we're going to do data processing for the last 10, 20 years, as we believe at Confluent. And because the key thing about stream processing is that you don't necessarily have to store data to effectively be able to process it. That's the beauty of stream processing. Whenever you have a use case where you want to have instant actionable insight, you have to use stream processing, right? Because the old days, 30 years ago, what we used to do? We collect the data, we store it into a database, SQL or no SQL, and then come up with programs that would read the data to process. And then we're going to have actionable insights, right? But there's a delay between this. Between the time you collect the data and the time you actually process the data, there's a 24-hour period because usually batches happen at midnight, right? So what if you want to have actionable insights? Where's my endpoints? Jaeger. All right, find traces. Probably is this one. What if you want to have actionable insights at the speed of a thought? Like, this is my whole architecture being observable. This is the whole point of the presentation, right? So by the time I read the information from Twitter, which is this component which does Kafka Connect, it connects to Twitter and brings data in. By the time I send the data to the winners stream, which is the Redis cache, there was a whole point of processing in between, right? But without further ado, try to sum up all those milliseconds right here. You're probably going to end up with what? 20 milliseconds? It means that the decision of who is the winner happens like this, in a snap of a finger, or a blink of an eye. Or like my 8 years old kind of accurately described, Daddy is just like a fart, right? So it's really, really fast. So that's the power of stream processing, because you don't have to wait until data is ready for you. And that's what Kafka gives to you. Kafka gives you the information in real time, so you can process it. This is a bit of a kind of a slightly different view of Kafka, because most people see Kafka as a messaging technology, right? Like a big pipe that connects in one side and delivers to the other. So what we introduced now in Kafka is the ability to process data before delivering it, right? Okay, so far so good. Everybody's kind of comfortable to stream processing right now? Can I move forward? All right, cool. So let's talk about what really matters, which is, oh, by the way, this whole application I made available in my GitHub account. So if you want to see how I did this magic, right? So the source code is there. It's free, all right? And it's open source, like always. Okay, let's talk about the observability challenges. How many of you have implemented observability somehow? Whatever technology, regardless of the technology. Actually, let me give you one step back. Good for you. You want a t-shirt? Like a, let me see what sizes I have. Large? All right, but before I give it to you, what technology did you use? Just for out of curiosity. Grafana, good, all right. That's a good one. Hey, Grafana. All right, so observability. So first of all, why this is important? I like to explain observability by the real value that it delivers. I mean, there's a whole technical, beautiful, easy to pronounce explanation about what observability is. And some of the speakers throughout the day, they kind of touch base of the concept throughout the day. But the way I like to explain observability, it's focusing on the value, which is, if you do monitoring, more specifically, if you do troubleshooting in your environment, how long it takes until the time someone complaining about the problem to you effectively solving the problem, right? What is the portion of the time you spend finding where the problem is compared to effectively how long you spend some time fixing the problem, all right? So if we go back 30 years ago, all the applications were kind of running into databases, right? We used to write start procedures into the database. So how many layers do you have to investigate to find out what the problem was? One, right? But these days, 2019, we have microservices, right? Where we have a bunch of microservices communicating with each other. And if we go back a little bit into our architecture here, this one. If someone says, hey, DevOps guys, all right, I'm feeling that this architecture here is kind of getting slow. Where are you going to start seeing where the source of the slowness? Without observability, you would have to keep monitoring every single layer of this presentation here. Every single layer individually using Grafana or any other technology, right? But this is an exhausting process. There are intelligent and better ways to do this, which is using observability, right? So just like this. This thing you were kind of seeing here, not sure if it's too small for the people in the back, right? Let me try to increase the font a little bit. This thing here, in a way, it gives you a zoom where the problem is, right? So for example, because all the layers are kind of happening very fast, but imagine, just assume, for the sake of the understanding, just assume that this guy over here, what I call gases stage 3, it took a long time, right? So you, as an ops guy, could simply go to this UI right here, do a zoom in this is one transaction. From the number of transactions, right, this is one, and you can see the whole transaction end to end and the amount of time for each one of the layers, all right? So you as an ops guy could do a technology like this to, okay, oh, this is the guy that I have to start investigating. So again, the time someone complaining to me about the problem to the time you start investigating does this. This is the value of observability, all right? Reduce the time you spend troubleshooting. This is not going to troubleshoot for you. This is not a magic, right? You still have to sit down and troubleshoot throughout the logs or come up with something, but as I said, you won't lose time, precious time, okay? All right, so observability is cool. I got that part. What else? There is some observability is implemented using the concept of tracers. Right? Tracers are some building blocks that you install in your applications or microservices or whatever you want to call it, right? Your software in general. And there are multiple programming languages available to install that, right? Those are some examples of tracers. What I'm using here for this demo is this one right here called Jaeger, right? This is kind of a, this is one of, I think was one of the first. It was invented originally at Uber. So they kind of implemented this whole observability thing using what was not called Jaeger at that time, right? And then they open sourced it. So it became Jaeger eventually, right? But there are Instana, Lightstep. Where is Zipkin? Zipkin was the first, right? Shame on me, I didn't put Zipkin here. My bad, right? My bad, because it should be here. So there's Zipkin as well. But the point is, no matter what tracer you are using here, what we have something called open tracing, which is a high-level API where you as a developer can instrument your code with that API. And you can start using Zipkin, for instance. And if you're not happy with Zipkin, you can simply switch to Jaeger, for example, and your code will be the same because it's a standard API, it's open tracing, right? This is the coolness of this technology, all right? So it became extremely easy these days to bring observability to applications. So there are multiple programming language support, there are multiple tracers, there's a large community supporting it. So in other words, there are no excuses for not to use it, guys. Simply put, I think you should be using it, if not, all right? Okay, so let's talk about the problems that I mentioned. Oh, of course, does it work with microservices? Yeah, it's kind of obvious. And I put this slide right here strategically because observability kind of grew very along with microservices. Because if you think about it, microservices is a bunch of distributed services running into a network talking to each other, exchanging messages, right? And between those messages exchanges, you have to put the observability code, right? So you can trace all the communication chain and come up with a UI just like I showed to you, right? Which is the cool part of observability, right? So, and there are technologies kind of make it easy for implement observability in microservices. So for example, how many of you have implemented microservices before? Some projects using microservices. For those of you that raised their hands, how many of you have used sidecar patterns? You know what sidecar patterns are? So sidecar pattern is kind of a neutral technology that takes care of the whole communication in a network level for you. So instead of, look how easy it is. Instead of putting the instrumentation code into each microservices, imagine that you have 200 of them. Instead of instrumenting 200 of them, you can simply go to this sidecar pattern. Because after all the messages pass through here, right? So it kind of gets very easy. So sidecar is a concept, is a design pattern, right? The implementation is Istio or any other technology that's kind of make it available open source, right? But what is the point of all of this? Because even with something so cool and beautiful like observability and open tracing and all those technologies, there are problems, all right? There are situations that you as a developer or as a DevOps engineer or simply as a human being, right? No matter what your role is, you have to solve it. So the first one is the problem of collaboration between teams, right? Typical examples include, for example, you work for a company A, and part of your development is internal, right? So you kind of own the decisions of what technologies or what tracers or how you're going to implement observability and the code that your team produces, right? However, the other part of the implementation is kind of made offshore for some software factory offshore. How are you going to ensure, if you're not forcing contracts in between them, right, that the guy in the other end, probably halfway up the ocean, is going to implement observability the way you need, right? So communication between problems kind of creates this friction of how do you ensure success, right? That's a human problem. There's no kind of a magic bullet for it, right? The second problem is the very own existence of microservices and serverless, function as a service, right? Why is that? Let me give you an example. Do you know what serverless is? Have you heard about the term serverless? Everybody's kind of comfortable. Can I assume that if I continue talking, nobody's going to make me this question mark faces? All right, good, because there are no question mark faces so far, so it's good. All right, cool. So serverless or functions is kind of a unit of deployment, right? Or same goes to microservices. It's fair to assume that the best place to put your observable code is into a single function or a single microservice, because they are a unit of work, right? They do the whole job. They are small, they're focuses, and they do one thing good only, correct? So, if you have one function, how many observability code or tracing code are you going to implement for that particular one function? One. That's the answer. One, right? Because that's the unit of work. But that is the problem in this, because sometimes your function is only the entry point of something larger. For example, if you ask me, remember that I told you that when I speak to, I'm not to pronounce her name, the device built from Amazon that you know that's present right here with me, right? When I talk to her, she's actually invoking a AWS Lambda function. But AWS function is only an entry point. It receives the request, but it delegates to something internal that effectively does the whole accessing Redis cache and do the job, do the querying. Remember I told you that if there are two winners, it's going to loop over who is the newest timestamp. So this whole logic is spread over the Lambda function and something else. So sometimes, what I'm trying to say is, sometimes you have to make sure a unit of function, which is pretty small, is also broken down into the whole communication layer within the function. Same goes to microservices. Maybe you have a very small focused microservices, but if you look at closer, and that's where the title, Getting Superman X-Ray Vision come from, right? If you look closer, your microservices does way more than simply the main function, which is the entry point of the invocation, right? So you have to take care of this. And the reason I'm highlighting all of this, guys, as a problem, okay? Oh, I am on the slide already. The reason I'm highlighting this as a problem is because there are no technology on Earth that's going to automatically map your functions, because the developer needs to do that, all right? There's no, put all the observable code into a communication sidecar parent and everything's going to automatically work for you, because every developer kind of gets the domain problem and breaks down the complexity into multiple reusable functions, right? So you have to come up with this. So this is how the problem. The third problem is when everything is kind of, most of the web services or microservices these days are based on REST and JSON. Therefore, they're actually implemented over HTTP, right? Which has the concept of headers. And this is how Jaeger, Zipkin, and any other tracer kind of puts the information in the request, and the request is kind of a carryover the whole distributed chain, all right? Because the existence of headers. But what if you are dealing with something that doesn't have headers, some binary protocol? Sometimes you have to deal with them. Not everything's kind of it's going to be all HTTP and or that. I think I was kind of hearing our friends from Spark and Z before, and they were kind of mentioned that part of this transformation strategy required them to kind of rethink how they communicate with the external systems, right? So some of these external systems might not be based on HTTP. You have to deal with them. So that's going to be a problem, right? Pub-subscribe architecture is where the Kafka came from, right? So when you have request-reply architectures such as HTTP, right? There's one transaction. The transaction starts on the request. The endpoint kind of processes the request, sends the response back, and that's it. This is one whole transaction. But in a publish subscriber architecture, there is a producer, right, that writes the code to Kafka, for example, writes the data to Kafka, and then the transaction finishes. Right there. The consumer, or subscribers, as you want to call them, it will eventually pull the data out 1 day later, 1 week later, no matter when. All right? So they're separated in two different transactions. So it's not that easy to kind of implement observability in this type of architecture. Same goes if you are dealing with JMS-based implementations as well, right? So that's a problem. And lastly, sometimes you are not dealing with technologies that have the source code, all right? How many of you can say, what is the problem in this case? Like, imagine that you have something, a black box, right? And this black box is part of your transaction. Data pass through into that black box, and sometimes if you don't put the observability code into that black box, you will have a hole in your observable code, right? All the tracing will be there, and then you have a gap. That's your black box. And because you don't have the source code of that application or JVM or process, you are not able to put the observability code. You cannot write your tracing code right there, simply because the source code is not available. When I say it's not available, sometimes it is available, but you're not supposed to change it. Like, perhaps it's an application that somewhere else wrote, right? And you don't have the rights to change the code. I'm surrounded by robots. That's the fact. You remember, have you seen the Terminator, The Rise of Machines? I think it's this that's going on right here. So the point is, sometimes you don't have the source code of your application. So you have to deal with these situations right there. And that's why I'm going to show you right now how to solve these problems, right? And by the way, I kind of listed here 5 problems. Those are the 5 main problems when you are dealing with observability. And as you can see here, more than 50% of them are related to the stream processing arena, all right? And those are the ones that I'm going to touch base right here. Simply because, as I told you, collaboration between teams. There's no technology to solve this problem. This is a human problem, all right? The problem of the rise of microservices and serverless, there's no technology to solve this problem. This is, again, a human problem, all right? How developers break down the problem into multiple parts is hard to figure out automatically, all right? So that's why I'm going to concentrate into these 3 points right here. Before I continue, is there any questions so far? We're cool? All right? All right, so let's talk about the best practices for Kafka and how do we solve those 3 bullets right there, right? The first one is, if you are dealing with Apache Kafka to implement a stream processing architecture in your project, all right? Or you will be using Kafka in your project, make sure you use Kafka with a later release than 0.11. Why is that? Because this is where we introduced the concept of headers into Kafka. Without headers, nothing's going to work. Absolutely nothing, right? And this is important because sometimes you inherit the technology decisions from somewhere else. Like, for example, you remember the example I gave to you about sometimes part of your code is implemented offshore, and the team, wherever they are, kind of decided that they would be using Kafka 0.9, for example. So it's up to you to tell them, no, we have to use something greater than 0.9 because we are interested into observability, right? And without this release of Kafka, it won't be possible, okay? So keep in mind of this. By the way, we are in Kafka 2.0, 2.1 actually, in the community version. So if someone tells you that they are planning to use Kafka 0.9, punch them in their face because it's unacceptable. Come on, they're way behind. All right, open tracing contribution. So again, this is a URL for a source code. So the open tracing project is an open source project, which carries the whole implementation of what open tracing does. The high-level APIs, the low-level APIs, the integration with the tracers, et cetera, et cetera. But there is a kind of a, how would call it, an addendum to this project, what they call open source, open trace contributions, which essentially, they have one called Apache Kafka instrumentation, which is pretty cool. I use it in this implementation right here in this demo. Remember that this architecture has a Spring Boot application, which is responsible for processing the tweets that are coming from there. So that Spring Boot application, I use this instrumentation right there. So I use the code available for this, and the code is very easy to use. Like either you can use what we call interceptors or decorators, right? I'm not getting into too much technical details about the differences between them, but for keeping things short and simple, try to use interceptors as much as possible, all right? Imagine interceptors like something that you simply put one line of code saying, I'm using interceptors, period. Everything is going to automatically work for you, all right? So I like it because the simplicity of things, all right? And these open tracing contributions are good because they allow you to put the code of observability into your applications very easily. But there is one precondition with this point, which is you have to have the source code, right? There's no way to say the code to use interceptors if you don't have access to the code. Right? Make sense? Okay? So the third tip is this is the second open source project that someone's keep calling like tracing support for closed JVM. This is a terrible lame name, and I can get the right to say that's a lame name because this open source that I created. So I am the who to blame, right? Because the lame name, all right? So this is kind of an extension of open source, open tracing contributions that I kind of wrote. It uses the same technology of interceptors. So this is one line of code that you can kind of simply put in your applications. However, the main difference is that it automatically created traces for you. So you would not have to create the tracer by your own, write the code for it, so it does automatically. So it's very interesting if you don't have the source code of your application, or you have the source of your application, but you are not supposed to change it, right? So I keep telling you that, oh, you simply tell your application to use the interceptors, but what I am effectively telling this is a properties file. You don't have to change the code, either Java code or C# code or C++ code or Node.js code. The code remains unchanged, right? You go to a properties file that's external to your applications. So you can change it, right? You go to a bash, go there, VI, which is I'm still planning to learn until next year, remember, right? So you say you are using the interceptors, and that's it. Run your application. So it works pretty fine. So that is what I'm using, by the way, in the KSQL part. Because KSQL is just a server, is a process, is a JVM that you start up, and it kind of joins, it forms a cluster by itself, but you don't have the source code of KSQL. It's a bash script or a Windows script, PowerShell script, that you can simply start, and then voila, the JVM is there. So for those situations, you can use this code right here, okay? Now I'm seeing a little bit of some question mark faces. I'm wondering if this is, maybe you're thinking, what type of beer they have in the happy hour? I don't know, that's a mystery, right? But the good news is that we're good. We're good to go. We're good to have some beer, right? So guys, the last thing I would like to highlight for you is, first of all, thank you, right? Because you're the brave guys that spend the whole day kind of improving ourselves as human beings, so salutes for you. And if you want to know more about Kafka specifically and stream processing, I would highly recommend to join this Slack channel right here. All right? This Slack channel is kind of backed by the Confluent, which is, as you may know, is the company behind Kafka. And pretty much who responds to those channels is the people that writes the code for Kafka, the Apache Kafka commuters. So if you ever have any questions about Kafka, that's the place to go. If someone doesn't respond to you there, then you can go to Stack Overflow, which is kind of works as well. Thanks, guys. All right.